humankind has long gazed into the star-sprinkled canvas of the night sky, speculating on the existence of extraterrestrial life. The question isn't new, nor is it simple. From ancient philosophers to modern scientists, the possibility of life beyond our blue planet has tickled our collective curiosity. One of the most intriguing concepts in this cosmic quandary is the Fermi paradox. Named after physicist Enrico Fermi, it highlights the contradiction between the high probability estimates for the existence of alien life and the sheer lack of evidence or contact. Consider this. There are billions of galaxies, each brimming with countless stars and planets. The universe is so vast, it's beyond our human comprehension. With such astronomical numbers, the notion of Earth being the only life-bearing planet seems almost absurd. So in the cosmic vastness, are we truly alone? Or is there a chance that there's someone or something out there? In the 1960s, astrophysicist Frank Drake attempted to quantify the probability of extraterrestrial civilizations with an equation. This equation, now famously known as the Drake equation, is a probabilistic argument used to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. To break it down, the Drake equation consists of several variables. It takes into account the rate of star formation, the fraction of those stars that have planetary systems, the number of planets that could potentially support life, the fraction of planets where life actually develops, the portion where intelligent life arises, the fraction that develop technology that releases detectable signs of their existence into space, and finally, the length of time such civilizations might be sending out those signals. The beauty and the mystery of the Drake equation is that it presents a wide range of possibilities. It's intriguing to note that even the most conservative estimates suggest that we're not alone in the universe. Now let's talk about the impact of recent discoveries on this equation. With the advent of powerful telescopes and advanced technology, we've been able to identify thousands of exoplanets, and a good number of them fall in the habitable zone. These are planets where conditions could be just right for life as we know it to exist. This has inevitably led to a shift in the values of some variables in the Drake equation. However, it's important to remember that the Drake equation isn't the ultimate answer to the question of extraterrestrial life. It's an exercise in understanding the vast number of variables that come into play when we try to calculate the probability of life beyond Earth. While the Drake equation doesn't provide a definitive answer, it certainly broadens our perspective on the potential for life beyond Earth. From the smallest microbe to the possibility of intelligent beings capable of interstellar communication, the universe might be teeming with life in forms we can barely imagine. Life, as we understand it, hinges on certain conditions. Consider the recipe for life on Earth: a dash of water, a sprinkle of carbon, and a stable environment that's just right. These ingredients, vital for life as we know it, are known as biosignatures. Water, the universal solvent, plays a crucial role in the chemistry of life. It allows molecules to mix, react, and create the complex structures that form living organisms. Carbon, with its ability to bond with other elements in a variety of ways, forms the backbone of organic molecules, including those found in life forms. A stable environment, on the other hand, provides the right conditions for these elements to interact over long periods of time, allowing life to take root and evolve. Scientists use these biosignatures as a guide in their search for life beyond Earth. It's like using a compass in the vast cosmic ocean. As our understanding of life evolves, so too does the scope of our extraterrestrial search. The quest for finding alien life is ongoing, with some fascinating leads. We stand on the brink of what could be an era-defining discovery, and every day, our search grows more robust, more refined, and more revealing. Consider the Mars rovers, those tireless explorers of the Martian landscape. These robotic emissaries have been scouring the red planet for years, drilling into its surface, analyzing its soil and atmosphere. They're looking for signs of microbial life, evidence that Mars, our cosmic neighbor, may not be as barren as it first appears. Then there's Europa, one of Jupiter's largest moons. Beneath its icy surface, there could be a vast subsurface ocean kept warm by tidal heating. This tantalizing possibility has led many to speculate that Europa might harbor life. Future missions are already being planned to investigate this icy world further. And as we look beyond our own solar system, the James Webb Space Telescope is set to take us to new frontiers of discovery. This mighty eye in the sky is expected to peer back into the early universe, uncovering secrets about the formation of stars and galaxies. But it will also search for planets beyond our solar system, potentially finding worlds that could support life. Of course, we can't forget the search for extraterrestrial intelligence, or SETI. This project has been tirelessly scanning the skies for decades, listening for signals that might indicate the presence of an advanced civilization. Who knows what message we might someday receive? The universe is an enigma, its secrets veiled in the cosmos. As we continue our quest, each day brings us closer to potentially answering the question, are we alone? Our journey is far from over. The search continues. We are, after all, explorers, driven by curiosity and the tantalizing possibility that, somewhere out there in the vastness of space, we might find company.